Hi guys. All right, so today we're talking about average rate of change. And really all this is its slope between 2 points. That's it. That's all it is. So you guys have found slope before, like 1.5 million times. So what we're going to just be doing is the slope between 2 points. Now see how the slope kind of changes in this picture? As you go, it's steeper, and then it goes kind of flat, and then it turns negative. So your slope changes along that line. Well, the average rate of change is just going to find the slope between those 2 points. That's all it's going to find. So the average rate of change, wow, that was great. Change, there we go, that was better. Between 2 points from where x1 is a and x2 is b, and a function of f of x is defined as the following formula. Really, all it is you're finding the difference in x, so you do b minus a. You're finding the difference in y, which is f of b minus f of a, and then you put your change in y over change in x, because your y is always, you are always better than your x. It's a fact. All right, so like why I love to do this is it's easiest to see on a graph. So the change in x is going to be this way. So I can visually see that the change in x is going from 1 to 6, which is a distance of 5. And the change in y, I can visually see that the distance is from a 2 to a 6, which is a change of 4. So my slope, so this is equal to the slope of the secant, that's that line, that's called the secant line, which is a line directly connecting 2 points in a function. Secant line. Do you see it? It's a secant line. Okay, so I think this is where, yes, it asked me here. So we're finding the slope here. As you can see, the change in x, as we already did, was 5, because it's from 1 to 6. And then the change in y is 4. So then my change in y over change in x is 4/5. You can find this using the table. So we've got x and y. So we've got the point 1, 2. And we have the point 6, 6. So my change in x is a +5. My change in y is a +4. So then my slope or average rate of change is 4/5. You can also find it during the function, which is the 6 minus 1 over 6 minus 2 equals, I lied, 6 minus 2 over 6 minus 1. It's the y over the x. Gotta remember that. Okay, so 6 minus 2 over 6 minus 1 becomes 4/5. There are 3 ways to find the average rate of change. Okay, so let's use this example. I'm going to find 3, and then you guys are going to practice a few, okay? So we're going to determine the average rate of change on the given intervals using the graph of the function. So on A, it says find the average rate of change from x equals 1 to x equals 2. So x equals 1 is right here. X equals 2 is right here. So it wants to know what the average rate of change between those 2 points is. So I can find this using my graph, but I'm going to use my table. So I've got x, y. So this is 1, 0, and 2, -3. So my change in x is up 1. My change in y is down 3. So my average rate of change is -3 over 1, or you could just say -3. So now we're going to find the average rate of change from 0 to 2. So at 0, my function's at 5, and at 2, my function's at -3. So we're going to find the average rate of change of that. So we've got x, y, 0, and 5, and 2, -3. So my change in x is now +2, and my change in y is down 8. So then I would do -8 over 2 is -4. Okay, and we're going to do one more together, and then you guys are going to do a few. So you're going from x equals 3 to x equals 5. So those 2 points there. So I'm going to connect them. Now I'm going to make my cute little table. So my x at 3 is -4. My x is 5. My y is 0. So my average rate of change here is up 2. my change here is up 4. So then it would be 4 halves, which is 2. Okay, how you feeling? You feeling okay? All right, I want you to go ahead and try this one. So you're going to find the average rate of change for x equals 0 to x equals 6. You've got this.